high-leg delta system is a three-phase electrical service commonly found in North America. It offers the advantage of providing both three-phase power and a single-phase voltage suitable for lighting and receptacle circuits. However, the configuration introduces a higher voltage on one of the phases, commonly referred to as the high leg, stinger leg, wild leg, or orange leg. This high leg presents unique considerations for wiring and safety. In a high leg delta system, 3 transformers are interconnected. 2 of these transformers are typically center tapped, providing the neutral connection for the single-phase service. The 3rd transformer is connected to complete the delta configuration. The voltage between the high leg and the neutral is higher than the voltage between the other 2 phases and the neutral. This higher voltage is typically around 208 volts when the phase-to-phase voltage is 240 volts. It is crucial to properly identify and mark the high leg to prevent accidental connections and potential equipment damage or personal injury. The National Electrical Code, or NEC, addresses the high leg delta system in Article 408.3. The NEC mandates that the high leg, or phase with the higher voltage to ground, must be identified by an orange color marking or other effective means. This marking must be present throughout the system, including at the service equipment panel boards and any other points where connections are made. NEC Section 408.3 specifically requires that the high leg be placed in the B-phase position in the panel board. This standardization helps ensure consistent and safe wiring practices across different installations. However, local utility companies or power companies may have their own specific requirements for the placement of the high leg at the metering equipment. In the case of Long Island, New York, the local power company requires the high leg to be connected to the C phase at the metering equipment. This discrepancy between the NEC requirement of the B phase and the power company's requirement of the C phase can create confusion for electricians and installers. It is essential to understand the reasoning behind these differing requirements. The power company's requirement for the high leg to be on the C phase at the meter is likely due to their internal grid configuration and metering practices. Standardizing the phase arrangement at the meter helps them ensure accurate billing and system protection. On the other hand, the NEC requirement for the high leg to be on the B phase in the panel board is intended to standardize wiring practices within the customer's facility. This standardization helps prevent accidental connections and ensures that qualified electricians can safely work on the system regardless of the specific utility company's requirements. To properly address this discrepancy, electricians must carefully coordinate with both the power company and the local electrical inspector. It is essential to clearly communicate the power company's requirements to the inspector and to ensure that the installation complies with both the NEC and the utilities regulations. Here is how to handle the situation. Firstly, verify the power company's requirements. Obtain written documentation from the power company specifying their preferred phase arrangement for the high leg at the metering equipment. Secondly, consult with the local electrical inspector. Discuss the discrepancy between the NEC and the power company's requirements with the local electrical inspector and obtain their guidance on how to proceed. Thirdly, implement proper labeling and marking. Clearly label and mark the high leg throughout the system, including at the meter, the panel board, and any other connection points. Use orange-colored tape or other approved marking methods to identify the high leg. Fourthly, ensure proper wiring practices. Follow the NEC requirements for wiring the high leg in the panel board, ensuring that it is connected to the B phase position. Fifthly, provide clear documentation. Provide clear documentation to the customer, including a wiring diagram showing the phase arrangement at the meter and the panel board. This documentation will help ensure that future electricians and maintenance personnel understand the system configuration. It is important to note that the specific requirements for high leg delta systems can vary depending on the local jurisdiction and utility company. Always consult with the local authorities and power company to ensure compliance with all applicable regulations. Failure to properly install and maintain a high leg delta system can result in equipment damage, electrical shock, or even fire. Therefore, it is crucial to have a thorough understanding of the relevant codes and regulations and to follow safe wiring practices. Here is additional information about high leg delta systems. The voltage between the high leg and neutral is typically 1.732 times the voltage between the other two phases in neutral. For example, in a 240-volt delta system, the voltage between the high leg and neutral will be approximately 208 volts. The high leg should never be used to supply 120-volt loads. Only the other two phases should be used for this purpose. The high leg can be used to supply 240-volt single-phase loads or three-phase loads. When installing a high leg delta system, it is important to use properly sized conductors and overcurrent protection devices. Consult the NEC for the appropriate conductor ampacity and overcurrent protection requirements. Grounding is also critical for safety in a high leg delta system. The system must be properly grounded in accordance with the NEC requirements. Regular maintenance is essential to ensure the safe and reliable operation of a high leg delta system. This includes inspecting connections, testing overcurrent protection devices, and verifying the grounding system. Qualified electricians should perform all work on high leg delta systems. Improper wiring or maintenance can create hazardous conditions. In summary, high leg delta systems offer a versatile power solution but require careful attention to wiring and safety. Understanding the NEC requirements and coordinating with the local power company are essential for a safe and compliant installation. Remember to always prioritize safety and consult with qualified professionals when working with electrical systems. This overview is intended to provide general information about high leg delta systems and metering requirements. It is not a substitute for professional electrical advice. Always consult with a qualified electrician and your local authorities to ensure compliance with all applicable codes and regulations. In addition to the NEC and local utility requirements, there may be other applicable standards and regulations that govern the installation and operation of high leg delta systems. These standards may include those developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be familiar with all applicable standards and regulations to ensure safe and compliant installation. Furthermore, it is crucial to use high-quality materials and equipment when installing a high leg delta system. This includes conductors, overcurrent protection devices, transformers, and other components. Using substandard materials can compromise the safety and reliability of the system. Regular inspections and testing are also essential for maintaining the safety and reliability of a high leg delta system. These inspections should be performed by qualified electricians and should include a visual inspection of all components, as well as electrical testing to verify proper operation and grounding. Any deficiencies identified during these inspections should be promptly corrected. Finally, it is important to provide adequate training to personnel who will be working on or around high leg delta systems. This training should cover the hazards associated with these systems, as well as the proper procedures for working safely. By following these guidelines, you can help ensure the safe and reliable operation of high leg delta systems. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician and your local authorities to ensure compliance with all applicable codes and regulations. To reiterate the key points, firstly, the high leg delta system is a three-phase electrical service that provides both three-phase power and single-phase power. Secondly, the high leg has a higher voltage to ground than the other two phases. Thirdly, the NEC requires the high leg to be placed on the B phase in the panel board. Fourthly, local utility companies may have different requirements for the placement of the high leg at the metering equipment. Fifthly, it is essential to coordinate with the power company and the local electrical inspector to ensure compliance with all applicable regulations. Sixthly, proper labeling and marking of the high leg are crucial for safety. Seventhly, qualified electricians should perform all work on high leg delta systems. Remember to always prioritize safety and consult with qualified professionals when working with electrical systems. The safe and reliable operation of electrical systems depends on proper design, installation, and maintenance. By adhering to established codes and standards, and by working with qualified professionals, you can help ensure the safety of yourself and others. In addition to the technical aspects of high-leg delta systems, it is also important to consider the economic implications. High-leg delta systems can be a cost-effective solution for providing both three-phase power and single-phase power. However, the cost of installation and maintenance should be carefully considered. It is also important to consider the energy efficiency of the system. High-leg delta systems can be less energy efficient than other types of electrical systems, such as Y-connected systems. Therefore, it is important to select energy-efficient components and to implement energy-saving measures. By carefully considering both the technical and economic aspects of high-leg delta systems, you can make informed decisions about whether or not they are the right solution for your needs. And remember that this video is only for educational purposes and does not constitute professional advice.